Okay, well, the current Lyme tests are have a real problem with specificity. They are picking up antibodies that are directed against other bacteria that people have been exposed to, and this is sort of causing a lot of background noise, which means that if you make the test sensitive, you lose specificity and you're going to start identifying people who don't have the disease as positive. This is false positives, and it can be very confusing. The other thing that's a problem with current Lyme testing is a lot of practitioners get confused in the complexity of tests. They don't fully understand the differences between a screening test or first test and a second test, which is a Western blot. And the Western blot is like a barcode, and you have to have the right barcode. But even those bands that are in that barcode, that's based on 1990s technology, and there were some mistakes in it because there's some bands in there that are very cross-reactive with other bacteria, and we have a lot of problems with normal people having a positive band. A common one that almost 50% of normals will have is one at 41, and because that is against a portion of a bacteria called a flagellin. A flagellin is just a little tail that allows bacteria to move around, and any flagellated bacteria will create an antibody response that can be picked up in the Lyme test. That's a good example of things. So by reducing this background noise or picking up these background antibodies, you can make a much more sensitive test and still have a very specific test. That means that a low level of false positives and a high level of true positives. So it's really a breakthrough in how we are doing Lyme testing.
Great.
Well, Bio-Rad and I have been collaborating. My laboratory has been working on this project for over 10 years, and we really defined where antibodies bind on the proteins of the Lyme disease bacteria. And we were able to pick out spots of these proteins that were very specific to the Lyme disease bacteria, and then have a prototype test. And Bio-Rad was able to take that technology and further develop it and produce a test that's now available in the clinical laboratory and should really start to revolutionize Lyme testing for everybody. So my laboratory has been working on improving Lyme test technology for over 10 years. And one of the things we recognized is that we wanted to eliminate all this background noise, all these portions on the proteins of the bacteria that causes Lyme that are similar to proteins on other bacteria. So we determined where on these proteins antibodies bind, and we're able to define areas that were specific or unique to the Lyme disease bacteria. We then took these and built a prototype test out of it, and then Bio-Rad got involved and took this technology and further enhanced it and developed it into a test that can be used in the clinical lab. This will make a huge difference in testing for everybody, because now we have a test that's sensitive, especially in early disease, where it's so important to identify people with the infection early and not have the degree of false positive tests that all the current tests have.
That's awesome.